Good day, so I'm Jenny Paculba, Ordered Linear Search. So what is ordered linear search? Ordered linear search is a method of finding a value in a sorted list by checking each item one by one and stopping early if a larger value is found. So the core of this code is the ordered linear search function. It accepts two arguments, the n, which is I put an n for the number, and representing a sorted list of numbers and target. The value to be searched for within the list, the function iterates through the list using a for loop and range length n. Checking the element against the target, the crucial optimization lies in its conditional logic. So if ni equals the target, return I. L if ni is greater than the target, return -1. So the if condition checks if the current element ni matches the target. If a match is found, if a match is found, the function immediately returns the index I indicating the target's position in the list. This is the primary difference from a standard linear search. A match is differently identified and the search terminates. The elif condition checks if the current element ni is greater than the target. Since the list is sorted in ascending order, if an element is larger than the target, it implies that the target cannot exist anywhere farther in the list. The function thus returns -1 to signify that the target is not present. The final return -1 outside the loop acts as a default return value if the loop completes without finding the target. So here the code is going to be tested using by using three cases. So here for the sorted list, 2, 4, 6, 8, and 9. So it is in order. The number is in order. Print ordered linear search, and then print searching for 4 in sorted list found at the index. So this section here, when the print section or the the print section, this section showcases how to call the function and interprets its output. So the f strings, as you can see, there's a f strings there. uh, it enhances the output's readability by directly embedding the search results within the printed messages. So here we have the printf searching for 4 in the sorted list. So the sorted list, which is the 2, 4, 6, 8, and 9. So the compiler is going to find the number 4 in the sorted list, which is the index. So the output of this one, this the print searching for 4 in the sorted list, is 1. So this code is given to provide a functional implementation of an ordered linear search. So here is the output for the ordered linear search. So the unordered linear search, also known as sequential search, is one of the simplest search techniques. It involves checking each element of a list one by one until the desired element, known as the target, is found or of the end of the list is reached. This technique does not require the list to be sorted, making it ideal for unsorted or unordered collections. So here we have the testing the function. Here we defined a list sorted which contains 6 sorted integers. Although the list is sorted, this is irrelevant for an ordered linear search. It would work on the same on an unsorted list. First test case, we have the print searching for 3 sorted lists found at index, an ordered linear search for test list 3. We were searching for the number 3. So it exists in the list at index 1. So the function returns 1. So same goes here at the second test case, which is we are looking for the number 9, which is the function will return -1 because there is no number 9 there in the sorted list. So same goes for the third test case, print f searching for 6 in the sorted list, found at index unordered linear search sorted list 6. So the target is 6. The target 6 is present in the list at index 3, so the function returns 3. So here is the output of the unordered linear search. Binary search is one of the most efficient searching algorithms used when dealing with sorted lists or arrays. The R, this is the list that you want to find. The low and the high define the current search boundaries, starting at the beginning low equals 0 and end high len are -1 of the list. For the test cases, this prints a simple header to indicate the start of the search testing. So for the first test case, target is to present the middle match, which is the number 3. We're searching for the number 3 in a sorted list. So for the second test case, we are searching for the number 6. And for the third test case, we are searching for the number 5. So for the test case number 3, the original list is 10, 5, 8, and 3 is unsorted, which is not suitable for binary search. To solve this, the list is sorted first using sorted R9 unsorted, resulting in 3, 5, 8, and 10. Now the binary search function can be used correctly. The target 5 is found at index 1 of the sorted list. This is the output. So interpolation search is an advanced searching algorithm that improves on binary search by taking into account the distribution of data. Def interpolation search nums target low and high equals 0, len, and num. So the function parameter nums the sorted list in which we are searching. The target, the value we want to locate in the list. Low and high are the indices marking the current search range. While low is less than or equal to high and nums low is less than or equal to target, the loop continues as long as the search range is valid. Example is low less than or equal to high and the target lies between the values and nums low and nums high. So for the test case number 1, the target is the present R7, 1, 2, 3, 4, and 5. The target is number 4. So the 7 here is just to differentiate the multiple test cases. So same goes for the second test case, but the difference is the target 6 does not exist in the list. The algorithm uses interpolation to estimate a likely position. Since 6 is beyond the high value 5, the loop condition fails early and the function returns to -1. So for the third test case, it uses the unsorted list sorted before searching. But the list that I use, the unsorted, which is not suitable for the interpolation search. The list is sorted into 3, 4, 5, 7, 8. Now, interpolation search is applied and it successfully finds at index 2. So, the reason why nilagay ko yan siya dyan, even if it's not really suitable there, gusto ko malaman if pwede ba talaga. And thankfully, gumana naman, but it's not suitable. So, the interpolation search is a powerful algorithm, especially when dealing with large sorted lists that are evenly distributed. It improves over binary search by estimating the likely position of the target, potentially skipping over large portions of data. It requires the list to be sorted. So, this is the output.